The topic of this video is to talk about infinite geometric series. Now, in order to find the sum of a geometric series that goes to infinity, we need to talk about two other vocabulary words, diverging and converging, and how we're going to use the common ratio of a geometric sequence to be able to figure if a sequence diverges or converges. So if we break this down, if a geometric sequence is going to diverge, that means its common ratio is greater than 1, or its common ratio is less than -1. So meaning a number greater than 1 or less than -1. So like -10 or +22. Those common ratios would all cause the geometric sequence to diverge because the sequence is just going to continuously get larger and larger, and eventually it's going to end up at infinity anyways, so therefore it's just going to diverge and head straight to infinity. So if we're asked to find the sum of a geometric sequence that goes to infinity, that has a common ratio that's greater than 1 or a common ratio that's less than -1, that sum is going to equal infinity or negative infinity. Okay? So we can already determine that because the sequence is just continuously increasing. Now if we're talking about a geometric sequence that's going to converge, we're meaning that it's going to go to a specific value. It's eventually going to just say that the sum is going to equal this. And so in order to do that, the common ratio has to be between -1 and +1, but, not equal to 0. So for that to be the case, we would have the summation of the start, so my n value equaling 1, heading off to infinity. That's where I'm going to stop. As long as my r value fits within that range, it's going to a specific value, and we're going to call that L. It's going to go to a specific limit. It's going to end at a certain number. And so we can use a formula to help us calculate what that's going to be. So we really need to just focus on the r value of a common ratio. So as we look here at the very bottom, you have your term 0. That value is just part of the explicit rule. But the common ratio, if we see that based off of the previous criteria, we can determine then if it's going to diverge or converge, if my sum's going to end up at infinity or negative infinity, or is it going to go to a specific value or a specific limit. So let's take a look at some sequences. I want you to find the common ratio and then determine based off of that if the sequence will diverge or converge. So once you determine the common ratio says that the geometric sequence is going to converge, we have a specific formula that allows us to determine what it's going to converge to. And so we just want to go over this formula with you real quickly. So on the left, we have the sum of an infinite geometric series. That's what that S sub infinity means. So that's the sum of infinite geometric series. A sub 1, just like we've had in the past, just means the first term within that sequence, and you can calculate that through your explicit rule, or sometimes it's given to you. And then we're dividing that by 1 minus r. Remember, we're going to use parentheses, but r means your common ratio. Again, you can find that within your explicit rule, or you can calculate that within your sequence. Okay, so that's your common ratio. And that denominator is so important to make sure that you're putting that 1 minus r within parentheses so we can calculate our value that we're what we're going to. So let's take a look at example A and B. We'll start off with letter A. So here we have we have a converging summation notation, a converging geometric sequence. I know that it's converging because my R value is in between -1 and 1, and it's not equal to 0. So what I'm going to do then is I'm going to find my first term. And so I'm just going to go ahead and plug in 1 for n and do 342 times 0.1 to the nth power. When I do that, I'm going to get 34.2. And then I'm going to divide that by 1 minus 0.1, my R value. And what that's going to tell me is if I add up all of the terms from 1 to infinity for this sequence, my sum would then equal 38. Let's take a look at example letter B. Again, I can tell that this is a converging geometric sequence because, again, my R value is in between 0 and -1 and 1. So it's going to converge. And so again, I'm just going to go ahead and plug in 1 in for my n value and calculate that and get 3. And then I'm going to divide that by 1 minus 0.75, plugging in my R value using parentheses. So 3 divided by 1 minus 0.75 is going to equal 12. So again, if I take all the numbers from 1 to infinity, plugging that in for n, calculating that sequence, and I add all of them up, my sum would then equal 12. I would like you to use the formula to find the sum of the infinite geometric series for these 4. Be careful, making sure that you're looking at that common ratio to help you, and then practicing using the formula a sub 1 divided by 1 minus r.